So my name's Andrew Leonard. I work for Red Hat. I'm actually based at the IBM Hursley Labs down in Hampshire, a small Red Hat team there. I used to be IBM up to a few years ago, but I now work at Red Hat on the Adoptium team there that helps contribute to the Eclipse Adoptium project. And I'm going to talk about reproducible builds, Eclipse Adoptium, with the idea of secure supply chains in mind, and go over some of the aspects, reproducible builds, and the associated technologies and processes that all involves. So quickly, if you're not aware of what the Eclipse Adoptium project produces, we produce Temurin, which is the Eclipse Temurin project, which is a pre-built OpenJDK binaries at no cost. You can download them for free under the popular open source license. They're fully tested using the Aquavit Adoptium project, which is hundreds of thousands of high-quality tests across the usual suite of aspects, as well as the standard. We run them all through the Oracle's TCK compliance suite, etc., so that it's a compliant published version of build of Java. One of the aspects I've been involved with is the secure supply chain importance of, especially in the world today. And I shall go into that in more depth in the following slides. We also provide an API to automate your downloads, to keep your platforms up to date with the latest versions of Temurin. In numbers, so as of the April CPU release last month, we actually did 55 simultaneous builds across all the versions of OpenJDK from JDK 8 to JDK 22. So that's 8, 11, 17, 21, and 22. We're actually now approaching 1 billion downloads of Temurin as well. So that'll be a nice party moment when we hit that. SALSA, which you've probably heard of, which is secure the supply chain levels for software architecture. And we are level 3, build level 3 compliant for our Linux and Mac platforms. And SALSA is actually working on a level 4 soon, and we'll be hopefully moving towards that as well, which is all important in keeping a secure supply chain. We have 12 what we call strategic and enterprise members of the Eclipse Adoptium project, from companies like IBM, Red Hat, Microsoft, Google, a lot of the key important players, obviously, and Bloomberg is a relatively new one as a enterprise member. And we have lots of contributors, and more are welcome. And we build Temurin on all the sort of standard Windows, Linux, and Mac platforms, and also some of the more less popular but important platforms like AIX, Solaris, Z-Linux, RISC, Alpine. So as you see, there's quite a large amount of build pipelines involved with all those for every version of OpenJDK that we build and release every 3 months. So reproducible builds. I'm going to go on to what is a reproducible build to start with and why you want one. So at basic level, a reproducible build is basically ensuring that your build process can deterministically build your binary output identically bit for bit from the same input source and tooling. So if you compile the same source with the same compiler, it should produce identical bit for bit output. I'll go into the next slide, we'll talk about why. But I want to touch on the degrees of reproducibility, which is quite important, and I've graded them 1 to 3 here. And there's a reason for this, because it's actually easier to rebuild on the same machine, because there might be a reason why it reproduces on the same machine. I'll give an example coming up. Or you can have stronger reproducibility by standardizing your build environment using Docker containers, basically, such that you can better provide a determined build environment that will be consistent across separate machines. So that gives you a stronger degree of reproducibility. And the strongest is basically if you've guaranteed you're identically reproducible across different build environments, different on separate machines, and that is obviously the strongest. So you basically built in ensuring your build process is really independent of if it's an AMD processor as compared to an Intel, which can make a difference, as I discovered. At Eclipse Adoptium, we use options 2 and 3, combination of those for various platforms. And why do you want to be reproducible? Well, it's all to do with secure supply chains. It helps basically improve if your deterministic build process is not producing something different each time, you're making sure that your build process is far more high quality and gives you more provenance, that you're not introducing random malware or bad actors. And an important aspect of leveraging reproducible builds is if you can build independently on an independent environment, which you know is perhaps equally secure, but possibly independently set up by a third party or user, and they can do what I would call a validation build. And if it verifies bit for bit with an official build, then it gives you a lot stronger acceptance that you've got a high quality secure delivery. Another aspect that at our project that we also leverage reproducible builds for is if we're making changes to the Temurin build scripts processes, to make sure that we've not introduced regressions. If you rebuild the same thing using perhaps our re-architected script for whatever, and it produces identically the same binary as it did previously, then you know you're pretty confident that that's a high quality change, which is all important for the quality assurance. Software bill of materials. So this is a common industry standard now and helps define your build process and binary content in a standardized document. And an aspect that we leverage at Adoptium is the ability to reproduce identically based on input of an SBOM. So an SBOM can define exactly what is in a particular release and how it was built. And if you give that to a script, it could just rebuild it identically. So how do we get to reproducible OpenJDK builds? So I worked with the upstream OpenJDK project, led mainly by the Oracle build team in terms of this aspect of reproducible builds, and helped contribute roughly 20 changes I've contributed upstream with things like the extra date option on jar and JMod, so you can define specific timestamps, things like fixing bugs in the jar and JMod content ordering, and more obscure differences like non-determinism. If you happen to build in a different directory on your build machine, it was actually producing different native library output because that build path ended up in some debug symbol that ended up in lots of different changes. So you've really got to narrow down these fixes to make things truly reproducible. And with the work with that community, Eclipse Adoptium is helping to achieve that and maintain that as well, which is obviously important. In terms of maintaining it, in our Eclipse Adoptium Jenkins CI, we run regular comparable build test jobs, which rebuild and compare to ensure that our builds are reproducible. They basically rebuild the given target build on a different machine and do a compare. So as you can see there, nice and green. So we can continue monitoring that. Temurin provides SBOMs. We provide CycloneDX format JSON SBOMs, and these provide a definition of all the properties used to build that particular JDK, all the chars of the sources that were built, the versions of the build scripts, the version of the GCC compiler, if it's Linux, for example, what it was configured with, what the make arguments were, and a new item we've recently added, which ties into the where we're heading in terms of the higher levels of SALSA, is doing a complete dump of the build environment dependency, which we've utilizing strace for our Linux builds in this case, so we can provide provenance of exactly what packages a given Temurin build was built with, and you can tie those up with vulnerability scanning to check the provenance of a given Temurin binary. So that's new stuff that we're moving forward. I mentioned earlier about rebuilding from a release from an SBOM. We provide 2 new scripts for rebuilding Linux and Windows Temurin builds, basically just taking as the only input the SBOM for that release. And it will determine either download or check that your local dependencies meet the required as defined in that SBOM, and rebuild it identically, which you then gives someone the ability to have more satisfaction in the security of what they're downloading from Temurin. How are we doing? Zooming through this. Another new item that we've added in the April release is support for dev kits. So the term dev kit here is a sort of OpenJDK project term, which is basically a package of a toolchain used to build OpenJDK, and it aids in cross-compiling and for reproducible builds because it provides a standard compiler and sysroot so that you can rebuild reproducibly if you use the same dev kit elsewhere. And as I said, we've introduced this in the April release last month for JDK 21 and above. And basically, as I mentioned, it can enable an independent user or third party can, basically the dev kit is constructed by downloading from and certifying sysroot RPMs from CentOS or RHEL, and also obviously downloading the required GCC source and dependencies like binutils. And also we provided a script to help verify, because obviously trust in where you're verifying things is very important. So downloading RPMs from those repositories is sort of helped in that RPM does the verification for you using GPG, and similarly you can use GPG to verify these sources. Wow, this is the last slide, and this is probably the important bit on that last talk about dev kits. So one of the real benefits of reproducible builds and SBOMs and dev kits is that a third party or user can rebuild that dev kit in a secure environment based on the definition of that supplied dev kit. So you don't have to, because if you were to take the Eclipse Adoptium dev kit, you don't know if the dev kit that we're giving you is in some way infected, or if you call it. But if you can independently build it, and because of the standardization of the dev kit, you can do that. And I'm going to be writing some blogs very shortly on how to do that. You can independently build that exact same dev kit and rebuild the published Temurin based on the SBOM information on how it exactly was built, and verify that it's bit for bit identical to the official Temurin JDK that's published, thus providing a far higher level of validation on the security of the Temurin build supply chain. Okay, that was a bit of a rush. Any questions or aspects that you? Well, OpenJDK source. Yeah, OpenJDK source, yeah, which is obviously a combination of Java, native C code, C++, assembler, a whole swathe of different types of stuff that makes up OpenJDK. So the challenges of making reproducible classes, native libraries, it's quite a swathe of work that's been done with the OpenJDK community to make it reproducible. So yeah, as I mentioned, these two scripts here. The Linux one, Windows is a little bit trickier because of the Visual Studio install, but the Linux one here will actually look and download the required GCC defined by the SBOM, for example. But we're continuing improving these things because this is obviously a really important aspect of secure supply chains and to ensure that the quality of Eclipse Temurin builds are secure for all our users. Thank you. And importantly, join us on Slack if you want to get involved or message me on Slack. Please join us. We're open to contributors. Thank you. That's all right.